On the 29th of April 2019, the Parkes Radio Telescope in Australia captured a strange radio signal from the nearest neighbor of our solar system, the Proxima Centauri star. Every day, telescopes in different parts of the planet observe space in the hope of capturing a signal. The signal that astronomers dream of and fear so much.
Hello, mortals, human people. Welcome all, we beings, level, organic, fly, ghost, fly, rolling, fly, how fast you fly, so fast, so.
But so far, all the most powerful radio telescopes on Earth have been able to detect is Is it possible that one of those signals is the message we're waiting for from extraterrestrial civilizations? But what was unusual about the Proxima b signal? What kind of signals are we sending into space? What do we do if we actually get an answer? Why is it so difficult for us to understand signals from space? Let's start by figuring out the following thing. How do we even get signals from our galaxy and other galaxies? Is there really a huge radio receiver somewhere, and scientists are just turning the knob, hoping to catch an alien radio station? It's almost just like that. Only instead of the radio receiver, there are 42 satellite dishes with a diameter of 20 feet each. This Allen telescope array in Northern California was built explicitly for SETI, the Search for Extraterrestrial Intelligence projects. Apart from it, the SETI projects also use other radio telescopes. For example, the Parkes Radio Telescope in Australia, which captured BLC-1, the signal from Proxima Centauri. It's not just the closest star to our solar system. There are two exoplanets orbiting it, one of which is Proxima b, which is in the so-called habitable zone, which means it's potentially suitable for life. So we could get that radio signal from a technologically advanced civilization from a neighboring star system. Let's see what happened to the BLC-1 signal after Parkes Radio Telescope recorded it. How are signals from space decoded? Radio signals from Earth and other interference are eliminated from the received data. The recordings are then examined by researchers. BLC-1 has lain in the archive for over a year. It was only discovered in October 2020, and it looks like this. That's not how we imagined the alien message, is it? Of the 26 hours of data, researchers were able to single out 5 repetitive signals at a frequency of 980.2 thousandths of a megahertz. It's not enough to encrypt a full message, for example, with coordinates or information about extraterrestrial beings. If anyone tried to tell us anything, it was no more than hello. But what kind of signals from space are we responding to? Space seems absolutely quiet and lifeless to you and me. But radio telescopes record a huge amount of noises from quasars, pulsars, interstellar gas, and interference from Earth. How to understand what signals we need in this noise? Astronomers are looking for narrowband signals, which can be produced only by technological objects. Radio telescopes record tens of hours of data at several spots in space. The algorithms then process the records, filter out the excess, and most often there's nothing left. But that's just not the case with the signal from Proxima Centauri. It wasn't eliminated by automatic filters. In addition, the signal drifted over time, as if it was emitted by an orbiting object. What further evidence do scientists need? It's simple. The signal must be re-recorded. BLC-1 has not succeeded in it yet, but there are signals that the researchers recorded not just repeatedly, but with a periodicity of several days. These are FRB, fast radio bursts. This signal was recorded by scientists in 2012. They've been watching its source for 5 years, and they've found out that this rapid radio burst has its own schedule. Its activity lasts 90 Earth days. Then for 67 days, it disappears from radar. If this is a broadcast from an extraterrestrial civilization, it's unlikely they're trying to communicate or waiting for an answer. It's more like a pointless message into space just to signal their existence. Despite the fact that a total of 700 FRB signals were recorded, don't know what could emit them. There's a theory that it's magnetars, neutron stars with a powerful magnetic field. But could it be the signal from extraterrestrial civilization we've been looking for so long? We get upset that we don't get from the space signals what we expect from them, but we also send very ambiguous and strange signals into interstellar space. And what did humanity send into space? And is it possible to decode our messages? We sent the first radio message into space from Earth in 1974 from the Arecibo Observatory in Puerto Rico. The message is encrypted with a binary code that scientists sent as a radio signal. If the receivers understand us correctly and arrange the bits as we've intended, they will get an image that looks like this. Yeah, that's exactly what the aliens should know about us. We live in the Minecraft universe. In fact, there's a coded basic information about the structure of the DNA molecule, the structure of the solar system, and numbers.
Mathematics is the only truly universal language, Senator.
Even if it can't be decoded, the message itself will be different from the natural signals in space. This means that an extraterrestrial civilization will be able to understand that it has been sent by intelligent beings. Or not. Guess how many times we've duplicated our message for it not to be missed for sure? 0 times. Hopefully, very attentive aliens live in M13 cluster where we sent the signal, but we'll never know it. It will take about 25,000 years to deliver the signal. In addition to the Arecibo message, several other messages were sent from Earth. Pioneer 10 and Pioneer 11, spacecraft that made a flight in 1972 and one 1973 to explore Jupiter and Saturn, can tell aliens something about our civilization. Plaques were attached to both aircraft with images of humans, distances from our solar system to 14 pulsars and the center of the galaxy. But the most famous message from us into space is the Voyager Golden Record. There are greetings in 55 languages, musical compositions, sounds of nature, photographs of people and the Earth recorded on it. There's also a speech by Jimmy Carter, the 39th President of the United States, and a 1-hour brainwave recording of science popularizer Anne Druyan, who spent an hour thinking about Earth history. In fact, we don't know what extraterrestrial intelligence would find easier to understand: brain activity recording or the instruction from NASA on how to play the Voyager Golden Record. For them, our drawings can be as incomprehensible as fast radio bursts for us. We don't know how extraterrestrial civilizations will react to our messages if they get them, but we can assume how it would be. Let's imagine that Voyager 1 has fallen into the hands of aliens, and they turned out to be so advanced that they figured out how to listen to the Golden Record after 3 attempts. The music from Earth didn't kill them, and they even reached the point of Jimmy Carter's speech on the tape. It would help them understand how our language functions, and maybe they would even record the answer for us with a request to send them an alphabet or an English for Beginners course. They would trace the location of the solar system upon instruction on the package of the record and send us a radio signal. What would we do? Let's assume the aliens who discovered Voyager turned out to be smarter than us and duplicated their signal. Then we would know for sure that these are not random outbursts. but a message from another civilization. And that's when panic would begin. While scientists would be decoding the signal, ordinary people would be following a Hollywood movie script, preparing for an alien invasion. Let's assume we've decoded a message from an extraterrestrial civilization. What's in it? The answer's two fundamental questions: the truth about the origin of the universe, or just hello. Most likely, they would have answered something like,
Got your message, but didn't understand anything. Didn't understand.
everything we sent into space was just to say, look what we can do. And if you already resent that scientists don't take it seriously, imagine that your government allocates a couple $1 billion to send messages to extraterrestrial civilizations. What would the reaction be? Most likely, everyone would explode with anger. So, what needs to be sent into space so that, firstly, we can be understood, and secondly, be provided with a precise answer? What if the problem is that scientists have been using the wrong approach this whole time? What if we send a signal into space that doesn't need to be decoded, but can't be ignored? I suggest broadcasting the song Baby Shark to the farthest reaches of the universe at regular intervals. If an extraterrestrial technogenic civilization exists, they'll definitely contact us and ask us to turn it off. Subscribe to the channel and offer your versions of
signals that